What is up, YouTube? And welcome to episode 19 of the Chaos Daily. So, yesterday was a really downer day for me. I was very frustrated with not really achieving the progress I was looking to achieve. And yeah, after I made yesterday's episode and set it for upload, I went and made myself some dinner. I'm standing there, as you do, cooking my sausages, just sizzling my sausages away. And then it hits me. Just like that. Eureka moment. I figured out how to solve this problem. I still have to go back to before I did all the structure and everything in the plane, right? Nothing's changed in that department. I've still got a lot of work ahead of me again. But I figured out why this isn't working. And it's down to a couple of reasons. First reason is this is the furthest I've got with doing this with an airplane. All my other designs either only got to the concept stage or just got to where I was putting structure in them. I've never gotten far enough to actually start putting components and stuff. I've always sort of pittered out at the end of each one of these projects. So this is new ground for me, right? I've never actually done this before. I'm still learning. So there's some leeway to give there. And one of the things that I'm learning, which I've just figured out, is you can't make function follow form. Not always, right? I'm sure there are some cases where that's the case. But for these very organic shaped planes of mine, these designs, I'm trying to make the form function. When really I need to make the form, I have to make the function separate, and then I have to overlay the two and adjust the form to the function. What do I mean by this is, well, I need to make the design of the plane, and then I need to make the layout of the components separately. So I know how I want the components and everything to go in the design when I design the plane. I'll have that in mind. But actually getting the layout, the spacing, the angles, and the sizes and clearances and everything just right is a real pain in the butt. So I've been tweaking the long easy all morning to just get it that little bit closer. And now it's at the point where I'm actually going to create a new part file, and it's going to be the layout of all the components. This includes any of the spars, control horns, servo mounts, battery mount, all of the bits and pieces that go in the plane, including going as far as maybe making the outlines for where the hatches to open it up to get to your servos and stuff, how you're going to access all your components. All of that stuff needs to be laid out. So that's going to be laid out in a separate thing. Then I'm going to bring it into the assembly and overlay the two in the same space. So they'll both be laid out based on the scene origin. And then from that, I can go back into the long easy and adjust because I had a bit too much dihedral in the wings, which was messing with the spars and everything for the ailerons, and it was messing with the fact that I couldn't get a spar running all the way to the tips to run a control rod through the spar, through the carbon fiber tube to get to the wingtips to do the split rudder thing. So yeah, I was making it more difficult for myself by just getting ahead of myself with the design without really then actually holding it up to the light of the components and going, hey, does this still mesh? No, it doesn't. So yeah, that's what I'm going to do now. I'm going to go over the layout, what I have planned, do some drawing on the screen, show you guys what I'm thinking, maybe get some input, because like I said, I've never actually done one of these before. I'm still learning. So this kind of thing is expected to happen. So yeah, let's jump into Inventor and then I'll show you what I've got. So I've got 4 servos, servo for each aileron, servo for the split rudder, and a servo for the elevator. They're all there in the midsection. This big blocky rectangular thing, that is the space for the battery, right? So what I've done is I've gone and looked at a bunch of different 6S batteries in the 4,000 milliamp hour range, looked at their different sizes, compared their different sizes, and thought, okay, so on average, we can get away with a 50 by 50 by 150 size space to put the battery in. So I've just mocked up that thing there to show this is where the battery needs to fit, and then I can also see if it still sits inside of the shape of the plane. I've also gone ahead, which I didn't mention, is I've made the tail piece that I spoke about in the previous episode. This is to run the wires off the motor. So they'll come off the motor at the back here and they'll drop through this pylon into the bottom here. And then you'll run your ESC somewhere in the bottom there, and I'll put your transmitter in the middle here somewhere, or your gyros or whatever else you want to put in here. Gyros and that, the gyros and the transmitters and stuff, I actually want to put them in the lid. So the lid that goes on basically the hatch, I want to mount all that stuff to that. So when you open it up, I'm probably going to use magnets, but we'll see. These are nice strong magnets and they're pretty cheap. So we'll design the form for that, but it all depends on 3D printing. Because if you're using FDM, making the spaces for those magnets is a little bit tricky, and getting the tolerances just right. Anyways, I'm getting off track. So I've got most of them all laid out here, and I just wanted to go through and show you guys what I have planned for how everything connects. if we jump into the side view, we have the elevator servo here, and we've got the elevator canards at the front here. The elevator canards will be attached to the airframe with a single 5mm carbon fiber tube. Runs through both of them pretty much the full length, and it hinges inside the fuselage. So you put the tube in the fuselage halfway, and then you slot a control horn over the tube, and then you push the tube the rest of the way through the fuselage. And then you use some CA or some epoxy to connect that control horn that's around the tube to the midpoint of the tube, so that if you turn that, it turns the whole tube. Then you put some epoxy or some CA onto your canards, you slot them on the ends of the tube, and now the tubes will turn with that control horn hinged through the pivot of the fuselage. Really simple, like so simple. Nothing crazy there. Now, that control horn, I can either put the servo up front, but I want to keep the weight further back. So that'll run with the control rod underneath the battery tray to the servo on its control horn. That sorts the canards out in the front. That's the easiest part, right? That's so simple. Now, so ailerons. Let's have a look at the ailerons, right? You got your two servos in there for the ailerons. Now what I was planning is you have your aileron cut out of the wing somewhere, and the aileron is hinged on another carbon fiber tube, another 5mm. I'm just going to use 5mm carbon fiber tubes throughout this whole build. Keep it simple, you only have to buy one kind of tube. And I'll keep the lengths, the maximum lengths, to under 500mm, so you can just buy those really cheap ones off eBay that come in 500mm lengths. You can buy a whole bunch of them, all for this build, not a problem, right? Let's just quickly draw up an aileron, right? So we've got an aileron in here, and then we got carbon fiber tube that runs into the wing here, through the aileron, all the way to the back here. So now the aileron is glued to the tube. So once you slot it in, once this goes together, it doesn't come apart again. Some people might have some gripes with that, but I'm keeping this simple. You put this plane together, the wings and everything, it all goes together, and then it doesn't come apart. The only things that are still removable are the access hatches and stuff. So this tube is fixed to the aileron. So if you twist the tube in here, it twists the aileron, and the aileron does its flappy thing, right? Then you glue a control horn on the end of the tube on the inside of the fuselage here, and you got your control horn on your servo, and there's a linkage between the two, and your servo controls the tube for the aileron, right? Nice and simple. Easy. Now, here comes the complicated part, right? So, for these rudders, and I'm still on the fence about this, doing it on the tips would be super cool. That's like maximum street cred to get a double split rudder on the tips with how small it is, with how small this whole plane is, how simple this whole plane is. If I get that working reliably, now here's the key word, reliably, then I'll do it. If I can think of a way to do it reliably, I will do it. But if not, I will cop out and put a rudder on the back of that pylon underneath the EDF. This back section here, I will put a rudder in here because that's high velocity air coming off the EDF. You don't need a very large rudder, you just need a little bit. It's enough to get it to do what it needs to do. Maybe, we'll see. But I would still like to do a full double split on the wingtips. Now, in order to do that, I did up a sketch on this beforehand, is you'd have this sort of rotating pulley on the servo. When the servo rotates one way, it pulls the line tight, and it comes here, and there'll be a little bend in here where the line will pull around a bend, which is not ideal. That's a point of friction. It could rub and snap the line. You might have to put like another pulley in there. I don't want to do that. It's just adding more complexity. That becomes then a very fiddly, complex piece with lots of moving parts. We want to avoid that. I do not want that. So with this option, it was with fishing gut line that ran through the main carbon fiber rod. So there's the diagonal carbon fiber tube that runs through the wing for the wing support, right? This line runs on the inside of that, so that makes your clear channel for that line to run through. It comes around to the end here where that tube just sticks out a bit and connects to the wingtip. And then that comes through and it pulls through the middle of a spring inside of a housing, and when it pulls forward, it pulls the block forward and it pushes those two levers out, which are also hinged on the wingtips, on the flaps on the wings, and those rudder flaps push out. That is a really great way to do it if I had more space. This is a very small area and very small confines, very fiddly, moving parts. 3D printing a lot of those parts might not work out because of how thin and skinny they are. So great idea, not the best idea. The next option is to do a single-sided split. On the real Long Easy, it uses only a single-sided split. And the easiest way to do that is to cut the wingtip down the middle, or just use the whole thing. I would prefer to use cutting it down the middle, and that way you still have a flat surface and the opening surface. That creates a drag face, a drogue. If you do the whole surface, you create basically like you do with a regular rudder, where you will be diverting airflow around the backside and on the front side. It's not going to create as much drag as if you keep one of them straight into the airflow, and then you create a large frontal face obstruction to the airflow, and that will give you better drag and better control. And it also adds a bit of rigidity to that vertical stable, the vertical tip, right? So keep one side solid, place a hinge on a cutout on the other half of it, and then on the bottom, where you put in a carbon fiber rod through as your, like a 1mm or 2mm rod, put that through as your hinge, and at the bottom where it comes out, the bottom of the hinge, you epoxy it or CA it to a control horn. That control horn sticks out forward of the flat. Okay, so let's try that again, right? So here we got the wingtip. Now if I get up in my nice light shot tool, and we have the carbon fiber spar that runs through the wing. Right, that comes that way. And now we create the split for the rudder. So that splits the wing like this. This side stays solid with the wing. And then this side has a hinge. And that hinge has got the hinge pivot that comes down, and then there is on the bottom side, on the inside of the wing, a control horn. And that control horn is attached to probably control rod or using fishing line as before, because if you use a control rod, it's a solid connection between the rudder split and the servo. If you use a fishing line or something, when it pulls the one side, the other side goes slack and it doesn't affect the other side. And that's what we want. We only want one side to split open when this actuates. So doing something like this is a lot more simple. I think I'll probably go with something like this. This will work a lot better. It'll be simpler to build. You just drop a carbon fiber rod through inside there, and I could probably design this flat and that hinge to be all one piece, so you sort of slot it into the spot and then you drop your carbon fiber rod in there, and you just put a tack of CA on the top, and then that holds it all together, and it's all good and dandy. And you'd probably run your fish gut through the wing first and poke it out, tie it off to that control horn, slot it in, and then drop your rod in. Yeah, something like that. So there are different ways for me to get around this. And these are the things I've been trying to work out. And the way I had done the structure on the wings and everything beforehand, the wings had, like I said, too much dihedral. So figuring all that out, getting that all to work, wasn't going to work. I needed to step back, start again, work out the layout properly from the beginning with the design, and sort of work the two simultaneously together rather than doing design, structure, and then components. I need to do components and structure sort of simultaneously on top of the design and working forward together like that. It's so much more, like, it messes with your head, and yesterday was so frustrating because I wasn't really getting anywhere. And last night, like I said, when I was cooking my sausages, I sort of had this eureka idea of creating a component layout part as a separate part that lays everything out how it's going to function, and laying it over and then making everything fit, and then I can go through and add the structure, and then I can still use that component layout as a way to use a Boolean operation to make negative cavities for all the components, and it would all work, and it would just make life simpler. Hopefully that helps explain things a little bit more. I've got a lot more work now to do because I have to go make that component layout, work everything out, and then think about things more deeply and more fully before I just charge ahead with the design and structure and everything. It's going to be a lot more involved than I thought on how to actually get this to work. I think the assumption I had originally with the design of this Long Easy being a simple aircraft, Long Easy was originally designed to be a simple kit build aircraft. That assumption that I had, thinking that would translate to this RC aircraft, I don't think held up very well. So there's a lot more complexity in it than I anticipated, and that's probably the issue that I've had, is I was expecting it to be simpler and it's getting harder and harder, and I'm like, no, this shouldn't be getting this hard so soon, right? Like, I planned this out. This is going against my expectations and my plans, so I need to rethink what I've done and why it's causing these problems for me moving forward. So now I need to go and lay out all those components, and then I can start on the structure and we can catch up and get further. This isn't a big deal because A, my printer's still not here. B, I'm still waiting for the EDF to arrive so I can get accurate measurements off of it. But it is a bit unfortunate because, like Simon, one of my patrons, he's already pre-ordered one of these. He's put down $50 to pre-order one. So, you know, I have to get there eventually, and we're like, what, a week into this? So it's not like I've taken a year and had no results. It's been a week, so I shouldn't be so hard on myself. But yeah, anyways, we'll leave it there for this episode. Like, subscribe if you haven't already. It really does help out the channel. Go check out my Patreon when you can. If you're not into doing Patreon, there is a donate link down below that you can check out. Chuck me a few bucks. It really helps out for buying components, carbon fiber rods, all that sort of stuff. And yeah, so I've been Chaos, and as always, expect the unexpected. And I will see you guys next time. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.